Welcome back, ladies and gentlemen. So, we are going to continue talking about the human impacts on our environment. And today we're going to pick up really talking about climate change. And in order to get into that idea of climate change, we have to understand one of the major effects that our atmosphere does for us. And that is this idea of this greenhouse effect. So, the greenhouse effect is actually kind of a good thing so long as it's being regulated appropriately. So the greenhouse effect is exactly kind of what it sounds like. It creates this greenhouse that is Earth. How do we do that? Well, things like carbon dioxide, water vapor, among other greenhouse gases, are trapped in our atmosphere. And that trapping of those gases helps to insulate Earth. So, as that sunlight and that solar radiation comes in through our atmosphere, things like infrared radiation coming from the sun hit Earth's surface and do get re radiated back to the atmosphere. Some of that heat, some of that solar radiation, that infrared radiation, kind of gets bounced around within the atmosphere, while some of it does get lost back out to space in the form of heat. The radiation, the heat that gets trapped by those greenhouse gases is what sort of helps to stabilize the overall global temperatures of our planet. And it is really important that this actually occurs. Without that atmosphere, we would end up looking something more like Mars, who has in fact lost the vast majority of its atmosphere. And as a result, is a pretty cold, desolate place, not really a habitable planet anymore. Even though, if we look at a lot of the characteristics of the planet, we do believe that it's possible that it was, in fact, very much Earth like at one point in time. So, it's a delicate balance here. We want to be able to trap enough heat to keep global temperatures at a level that is sustainable for life. Without the atmosphere at all, we end up being this cold, desolate uh, planet, not really good for the vast majority of things that live here. The problem, though, is if we over intensify this effect, we end up looking something more like Venus, where that planet's atmosphere is incredibly thick, traps even more energy and more heat than our current planet does or has historically been able to trap, and as a result has a pretty significantly high temperature at the surface.
What is the greenhouse effect? Earth is a comfortable place for living things. It's just the right temperature for plants and animals, including humans, to thrive. Why is Earth so special? Well, one reason is the greenhouse effect. A greenhouse is a building with glass walls and a glass roof. The clear glass allows sunlight to shine into the greenhouse while also trapping the sun's heat inside. This is how a greenhouse keeps plants warm even at night and in the winter. The greenhouse effect keeps Earth warm in pretty much the same way. Earth isn't surrounded by glass, but it is surrounded by a jacket of gases called the atmosphere. In the daytime, the sun shines through the atmosphere, warming Earth's surface. After the sun goes down, Earth's surface cools. This releases heat back into the air, but some of that heat is trapped by the gases in the atmosphere. These heat-trapping gases are called greenhouse gases. Carbon dioxide, water vapor, and methane are all examples of greenhouse gases. Earth needs a balance of greenhouse gases to maintain just the right temperature for living things. But some human activities are changing Earth's natural greenhouse effect. For example, burning fossil fuels like coal and oil releases more carbon dioxide into our atmosphere. These extra greenhouse gases can cause the atmosphere to trap more and more heat, leading to a warmer Earth. NASA satellites are constantly measuring the gases in our atmosphere from space. They've observed increases in the amounts of carbon dioxide and other greenhouse gases. The information from NASA satellites can help scientists figure out where greenhouse gases are coming from and how they are ending up in our atmosphere. This information will help us better understand the impact that greenhouse gases have on our climate and help us better understand this very special greenhouse that we call home.
So, what we have ended up seeing over the last century or so is this trend of increasing global temperatures. And we now know that this is, in fact, connected to increases in greenhouse gases that we are emitting. Are there certainly natural ebbs and flows to global temperatures? Yes, we know that those exist. We can see evidence of that throughout our geologic history, studying rock samples, ice samples, that sort of thing. That being said, we are seeing the increases in global temperatures happening at a rate that has never been recorded in history before. And we know that this is connected to things that humans are doing because when we alter those, we can see some minimal changes um, in experimentation, in actual natural studies. So, this sort of global warming, we've got to be careful with that term because what we're talking about here is global increase in temperature, right? So, what this really is connected to is climate change. We see these overall temperature increases across the globe as a whole, and we see the impacts that it's having, particularly at the poles, where our polar ice caps are melting at exponentially increasing rates. Glacier deposits are retreating at exponentially increasing rates. Um, and so that is having implications across the board. We are dumping more fresh water into the ocean, so we're slowing those sort of convection currents that are occurring in the oceans. So we're slowing those down, which means we're seeing changes in our extreme weather, hurricanes, typhoons, that sort of thing, um, bigger snowstorms, because it's also impacting our wind currents. And so we see things, if you ever watch the news and watch them do the weather, they talk about the jet stream and the troughs and crests, the dips in those jet streams are getting more and more intense. They're dipping further down into the US, for example, pulling in more Arctic air, so we get bigger, more intense winter storms. And as well, they'll retreat much further up into Canada than they ever used to either. And so we see much more severe tornadoes and um, summer weather patterns as well. So all of this is linked to climate change in the sense that we're seeing much more extreme differences in our seasonality and in our weather patterns than we ever saw before. And this isn't just a one season change. We've been seeing this over decades. And so we're seeing those swings happen and continue to happen and continue to get more extreme as we continue to see these greenhouse gases and their levels rise in our atmosphere.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. But isn't the climate always changing? What exactly is climate change and why should we care? Well, the Earth's climate has changed throughout history. Most of these slight changes are caused by small variations in the Earth's orbit. But climate change as we know it today is characterized by an abrupt increase in the Earth's temperature. It is estimated to have gotten 1.2 to 1.4 degrees Fahrenheit warmer in just the last century. 10 out of the last 13 years were the warmest on record. 97% of climate scientists agree that this new tendency is not caused by the variations of the Earth's orbit, but rather very likely caused by human activities. That means you and me. And since the Industrial Revolution, we have come a long way. Humans built airplanes, faster cars, developed remarkable technology, and learned how the natural resources around us can be used for our benefit. Although this has led to many wonderful inventions and advancements, like the device you're using to watch this video, or the ability to take a plane halfway around the world, It also means we've increased our consumption of natural resources and in turn released a lot of greenhouse gases into the atmosphere. Now, greenhouse gases occur naturally, but in excess can be dangerous to our planet. Modern human activities have increased the release of non-naturally occurring greenhouse gases because we have stepped up our demand for burning fossil fuels. The composition of greenhouse gases traps heat radiated from the sun. The more heat they trap, the warmer our planet gets. And as our planet gets warmer, we begin to feel the effects. One of climate change's biggest victims is our oceans. Oceans regulate the Earth's temperature and provide 50% of the Earth's oxygen. Now, climate change has increased the global temperature of the oceans by more than 0.3 degrees Fahrenheit since 1969. Although a warmer ocean might seem inviting to a beachgoer, it actually has devastating consequences for supporting life at sea. One of those consequences is ocean acidification, a direct effect of increased dissolved CO2. Since the late 18th century, ocean surface acidification has increased by 30%. A higher acid content means calcifying species, like oysters and clams and shallow water corals, are at risk, putting the entire ocean food web at risk. This is bad news for the 1 billion people relying on the ocean as its primary source of protein. Climate change has also caused the sea level to rise. Just in the last century, sea levels have risen 6.7 inches, but the rate in the last decade has nearly doubled. Sea levels have risen because as the ocean gets warmer, it swells. On top of that, glaciers and ice sheets are melting. Antarctica lost 36 cubic miles of ice between 2002 and 2005, and since 1994, each year on average, the Earth has lost 400 billion tons from its glaciers. That's like an ice cube 7.5 kilometers on a side, 4 miles on a side, melting and flowing into the sea. When all that ice melts, it fills up our oceans, and just like filling up a bathtub, the shores can't hold all that water, and coastal regions get flooded. Troubling signs of climate change are increased extreme weather events. Natural disasters like floods, tornadoes, and deadly heat waves are more obvious to humans because of their immediate impact and their sharing of the images in the media. Climate change, as we know it today, is change in our Earth's overall temperature with massive and permanent ramifications. Although its consequences can be planet-threatening, scientists still believe there are things we can do on a personal level to help. Recycle and reuse things. Walk or use public transportation to get to work. Turn off your electronics when you're not using them. Eat less meat. While you're at it, eat more locally grown vegetables and foods. And last but not least, spread your knowledge and concerns about climate change with others. When it comes to climate change, the main takeaway is that it's real. And although we are part of the cause, we can also be part of the solution.
Climate change is just too much. There's never any good news, only graphs that get more and more red and angry. Almost every year breaks some horrible record, from the harshest heat waves to the most rapid glacier melt. It's endless and relentless. We've known for decades that rapid climate change is being caused by the release of greenhouse gases. But instead of reducing them, in 2019 the world was emitting 50% more CO2 than in the year 2000. And emissions are still rising. Why is that? Why is it so hard to just stop emitting these gases? Our collective CO2 emissions can be expressed as a product of 4 factors and their relationship with each other. 2 of them explain why worldwide CO2 emissions are still rising, and 2 explain how we can stop that. Population size, economic growth, energy intensity, and emissions per energy unit produced. Number 1, population size. People need food, homes, and clothing, and they demand luxury products from iPhones to $1 cheeseburgers. More people, higher CO2 emissions. It's a very simple equation. The global population is growing, and according to the UN, it will level off at about 11 billion in 2100, which is 40% more than today. The only way to slow down this growth is investment in healthcare and access to contraception and education in developing countries. But even with massive investment, it will take a few decades for the effects of lower birth rates to manifest themselves. So the global population will keep growing for the foreseeable future, and as a consequence, global CO2 emissions will rise over the next few decades. Number 2, growth or getting richer. But it's not just about our numbers. The richer and more developed we are, the more emissions our lifestyle produces. A programmer in the US has a higher CO2 footprint than 50 farmers in Uganda. The world's wealth is growing almost everywhere. And although it's far from evenly distributed, economic growth has led to the highest standards of living and the largest reduction in extreme poverty in human history. Growth has become the dominant mantra of the world's economies, no matter what kind of political system they have. It's unlikely that rich countries will give up the concept of growth anytime soon. But even if they were to, developing countries want to become rich too. For billions of people, the end of growth would probably mean staying poor, and so developing countries are not willing to stop growing their economies. All in all, we can be sure that growth as a guiding economic ideology is not going to go away anytime soon. More countries and their citizens around the world will grow and become richer, while the rich economies will continue to grow their wealth. There are some signs that growth can be decoupled from CO2 emissions, but we're not close to that yet. As a consequence of this growth, CO2 emissions will rise. Okay, so far we've learned that because of population growth and economic growth, humanity's CO2 emissions will increase, which is the opposite of what should be happening. We need to slow, peak, and then reduce annual emissions. The next 2 factors describe how we can actually do this. Number 3, energy intensity. Energy intensity describes how efficiently we use energy. A street food vendor in rural Brazil might burn coal to cook, while a street food vendor in France might use an induction stove powered by nuclear energy. The latter is way more efficient. The more efficient something is, the less energy we need to do something, be it powering a metropolitan area or grilling a kebab. So making our technology more efficient and coming up with more efficient ways to organize our societies is one of the most important ways to reduce the modern world's CO2 dependency. This can mean everything from reducing power consumption with AI, the electrification of the transportation and industrial sectors, or sustainable concrete production. The opportunities for improvement are almost limitless, and human ingenuity can run wild. But we know that increasing efficiency alone will not be enough, mostly for 3 reasons. 1. Direct rebound effects. This means that once something becomes more efficient, it's used more, and so overall the increased efficiency does not lead to a reduction as impressive as you would first think. Or worse, sometimes more efficiency makes humans not use less of a resource, but more of it. When planes became more fuel efficient, ticket prices decreased and more people started to travel by plane. So making things more efficient does not automatically mean less energy use in total. It might have the opposite effect. 2. Indirect rebound effects. Sometimes when you save money on a thing that's become more efficient, you might spend it elsewhere. For example, if you buy a more fuel-efficient car, you save money on fuel and end up with extra funds in your bank account that you might spend on a vacation and take a flight with. So in the end, you might actually emit more CO2 despite getting a more efficient car. 3. And lastly, the more you optimize for efficiency, the harder and more expensive it becomes to get more efficient. So over time, the return on investment slows down. And with many technologies, we are already pretty efficient. But regardless of how efficient we make our economies, as long as we need at least some energy, we will have emissions. Efficiency alone won't create a zero-carbon world. This brings us to our last factor. Number 4, CO2 emissions per energy unit used, or our global carbon footprint. Humanity's global carbon footprint is the CO2 released per energy unit generated. For example, coal plants release much more CO2 than solar power per unit of energy. This relationship is crystal clear. The more fossil fuels we burn, the higher our CO2 output. Fossil fuels are the greatest lever humanity has right now. Of course, it's impossible to shut down coal and oil overnight without throwing society into chaos. But the reality is that we're not doing nearly enough to keep fossil fuels in the ground and use lower carbon alternatives. We need to do two things to speed the transition away from fossil fuels. First, we need to use the real leverage we have today with today's technology. There are a lot of things we can do extremely quickly. We can leave nuclear power plants online longer. We can cut subsidies to the fossil fuel industry and funnel them into renewables. We can price carbon emissions harshly and increase the price each year to create strong incentives for the world's industries to transition. We can enforce strict standards for energy efficiency and for any type of new construction. We can phase out fossil fuel vehicles. Next, we also need to invent new and better technology. Without new technologies and innovation, it will be impossible to achieve a zero CO2 emission world, be it from technologies like carbon capture or a new generation of nuclear power plants to new batteries that revolutionize the energy storage from renewables. But innovation takes time, years and decades, and we don't have this time. Every year we keep adding more carbon to the atmosphere. This means we can't keep relying on innovation alone. We need to find ways to reduce emissions today while we invent what we will need in the future. The less fossil fuel we burn over the next few years, the more time we give innovation to catch up. The more low-carbon energy infrastructure we build today, the more we can compensate for economic growth and the people born today. The more coal power plants in construction we stop from being finished, the more CO2 we save. Neither innovation nor the alternatives we're using today alone can solve rapid climate change. But innovation, together with a decisive move away from fossil fuels where it's possible today, could do it. Solving climate change will be complicated. We have to account for the needs of billions of people and the reality that right now, society runs mostly on fossil fuels. This will not change overnight, but it needs to change as quickly as possible. And it is still very much possible.